Good afternoon. My name is Pedro Fabricio Ibarra Leal, and today I will be presenting my thesis project titled Digital Audio Equalizer for Voice Isolation and Real-Time Recognition. This project focuses on improving voice clarity in noisy environments using signal processing techniques. Now we will move on into the introduction. There we go. So many audio systems have background noise and irrelevant frequencies that can make a spoken voice not so clear. So our aim with this project is to propose and design the implementation of a digital equalizer so that we can isolate voice components by filtering out all the unwanted frequencies. Now, the filtered output would be optimized for use in voice recognition. Um, it could also be used for other applications such as smart assistants and wearable devices like real-time embedded systems. Now we are going to move to the general objective. So the general objective for the project is to design a digital audio equalizer that isolates voice signals using digital filters. This would allow us to have real-time voice recognition and also aim for a minimal signal degradation. Now on to the specific objectives. The specific objectives of this project are to analyze the digital equalization techniques that can be used for voice isolation. This will mainly be the use of filters, being a high pass, low pass, band reject, or band pass filters. We will also be designing and implementing FIR and IIR digital filters. This is given that these are also some very efficient and useful filters. And then we are going to integrate this um, program into hardware. So this will give us this will open the window for us to finally do testing, which will lead us to our final objective, which is to validate the performance of our project by making a comparison between what is the original sample of audio that we had and the processed audio sample that we're going to make. And now we move on to the justification. So the project has importance in both social and disciplinary aspects. This is because socially it can improve voice recognition for people with hearing difficulties by using this project for the integration into hearing aids. This could impact the effectiveness of using these such devices. And from the disciplinary side, from an engineering standpoint, we would be applying mechatronics principles such as electronics, control systems, signal processing, and programming. Now we move on to theoretical framework. So the project is grounded in many areas of theory. Some of the most important are going to be the digital signal processing, especially analog to digital conversion. This is giving that we're going to take an analog signal, which would be the voice, and turning it into digital so that we can isolate it from all the background noise and other frequencies that might interrupt our desired output. We will also be covering filter design. This will be with mainly for FIR filters and IIR filters, for which we will be measuring or attempting to measure accuracy and efficiency. And we will also be using MATLAB for programming. This is because we have already made some other projects in MATLAB that have given us the knowledge to make such a program. Now, on to the expected results. We expect the system to be able to reduce up to 70% the background noise of our sample. We also expect to improve the clarity of the voice from these samples. And we will also expect to have a real-time result or operation. We are aiming for under 100 milliseconds. Another and lastly, our final expected result would be for it to be fully compatible with voice recognition modules. This would mean either other people's modules to be able to use this program, or, well, hopefully also our own project, which would be using a microphone and to be able to increase voice recognition. Now we move on to methodology. So for the methodology, we followed 4 main phases. First of all is literature review and tool selection. Then we will be moving on to design and simulation of filters in MATLAB. Then we move on to hardware integration with voice input and output. And finally, we would be going into testing under real conditions the accuracy and effectiveness of the voice recognition. Now we are going to move on to the project timeline. So the first weeks are going to be dedicated to research and design. This would be around the month in time. Then the next month would be dedicated to implementing the filtering and making the interface for the program. Now, the third month would be when we would start with the testing and optimization. This would be a bit more flexible. Well, most likely will be more flexible given the fact that testing cannot be constrained that easily to a time frame. This is given by the fact that we might have optimal results in the first attempts, or we might take a little bit longer than expected during testing. And finally, the last month would be mainly dedicated to the documentation and evaluation of the project. This also is a bit flexible given by the fact that documentation will most likely be, while not heavily emphasized, it will also be taking place in small quantities during all the other phases of the timeline. And finally, thank you for your attention. And also, lastly, I would like to show my bibliography. This was used for the whole thesis. This includes my quotes from my introduction, my background research section and the table where I compare all of this background research. Now that would be it. Thank you.